All right. For those of you that missed the notes, we're going to work on solving linear equations of systems with graph and tables. So a system of equations is two or more equations comprised of two or more related variables. So if we look at 5x plus 3y equals 6, x minus 4y equals 9, it's two equations with two variables. Now the way it works, if I have one equation with one variable, I can solve for x. So one equation I can solve with one variable. If I have two equations, I have two variables, x and y, I need two equations to be able to solve that system of equations. So one of the ways I can do it is find the solution to the equation, find the equations, and then graph them and see where they go through. Now I could do it this way, but because both of them have, because one of them has a y-intercept that is not a whole point, I'm better off using some type of mathematical solution to it. But first, let's talk about what the solutions look like. So solutions for a system of equation is a point or set of points where two lines cross. If I look at this system of equations, it's where two lines cross as a solution. So whatever this coordinate would be the solution to this system of equations. So this system would have one solution. If I have two lines graphed, and this is two lines, there's a line here, and there's a line here. That means that these two lines share all of their points. So every single point from this line is the same as every single point from this line. So instead of putting all real numbers, which I do not like, we will call it an infinite set. Now understand, on a star test or even a checkpoint, sometimes you will see the R as a solution. That's the closest thing to be an infinite set, so call it all real numbers. The reason why all real numbers is not a good description of the solution for this, so let's say these are my two equations graphed. An infinite set implies that there are an infinite number of points along this line, which is absolutely true. All real numbers means that any set of numbers should work. So if I chose, let's say, this point right here, that would be included in all real numbers, because whatever this point number is and whatever this number is a part of the set of all real numbers. However, this particular point is not on this line, so it is not a solution to this system of equations. So I don't like using the all real numbers as a solution. I'd prefer to use infinite set, or you can say infinite solutions. Now, if two lines that are the same line is an infinite set of solution, then two lines that are parallel to one another never cross, so there are no solutions. Or you can call it a zero set. Again, I don't like using just a zero because it looks too much like the number zero, and I don't want you to think that the number zero is a solution to this. I prefer it to be called no solutions or a zero set. A zero set means that there are zero solutions in the set of solutions. Now we're going to look at some example problems. So there are two ways to do it solving graphically. One involves a calculator, which we'll talk about later. The other one involves what are called y and x intercepts. We already know about y-intercepts. It's when a y crosses the y-axis, a line crosses the y-axis. An x-intercept is when an x crosses the x-axis. The solution point for any y-intercept is when x is 0. The solution point for any x-intercept is when y is 0. So we're going to create these two tables. I have these equations, x minus y equals 4 and x plus y equals 10. I can use a table that looks like this as a solution to that. So if I'm looking for a y-intercept, I replace x with 0. If I'm looking for an x-intercept, I replace y with 0. So if this is my first equation, we'll call that y1. This will be my second equation, y2. So all the points for this equation are going to be in this line. We're only going to do two. We're going to do the x and y intercept. So if I replace x minus y equals 4. If I replace the x with 0, I get 0 minus y equals 4, which means negative y equals 4. I don't like having a negative y, so I divide by negative 1, and I get that y equals negative 4. I could have also multiplied the whole thing by a negative 1 and changed the signs in the same way. Next, I replace the y with 0, and I just get x minus 0 equals 4, and that just means that x equals 4. So I'm going to plot that point. So 0, negative 4, I go to 0, down negative 4. And then I go 4, 0. I go over 4 and up 0. I made this straight edge by folding over a piece of paper. If you're on the STAR test, you can use the back of your formula sheet to create the same type of straight edge so that you'd be able to use it on a test. As far as finding a graph to use, if you're taking the STAR test and you've already finished number 7 and it has a graph on it, there's no reason you can't go back to that graph if you're on number 20 and use a graph that you're already finished with to do this type of trick. So next we'll need to, so this is the y1 equation. So next we'll need to graph the other line, but I need to find those other points. So I'm going to take x plus y equals 10, and I'm going to replace the x with 0. So I just get that y equals 10. Then I'll place the y with 0. So x plus 0 equals 10. So I'm left with a 10. So I'm going to graph 0, 10, and 10, 0. Connect them with a line. Now notice the way I do it is I take my pen and I put it on the point first. Then I push the straight edge up against that point, and then I move my straight edge down to connect those points, so I get a more exact point. Now this didn't go exactly through the point that I wanted. It's a little bit above it, but that's okay. It's right there, and that point is over 7 and up 3. So that is the solution to my system of equations. We'll try that one more time before we move on. One more guided practice, and this time I'm going to use a bit of a shortcut. Whenever I place x or y with 0, it's just going to zero that term out, even if it has a coefficient. So if it said 2x plus y equals 3 and I replace x with 0, 2 times 0 is going to be a 0. It's just y equals 3. So I don't like that box is open. This is y1, this is y2. I'm going to replace x with 0. So 0 plus y equals 3. So that just means that y equals 3. Now the next one I'm just going to leave off the variable that I'm replacing. So if I replace y with 0, I just end up with x equals 3. I'll do the same thing for the next one. X minus y equals negative 1. I'm going to replace the x with 0, leaving me negative y equals negative 1. This time I'm going to multiply the whole thing by a negative 1. So negative 1 times a negative y is y. Negative 1 times a negative 1 is positive 1. And again, I'm going to do x minus y equals negative 1. When I replace the y with 0, when I replace the x with 0, when I replace the y with 0, it just leaves me with x equals negative 1. So that's my solution, negative 1. I apologize, it looks like I had most of that off the screen when I was showing you that. So first I did x minus y equals negative 1. I replaced the x with 0, so that's why it's not present. I have negative y equals negative 1. I multiply by a negative 1, that changes to y equals 1. And then down here I had x minus y equals negative 1. That zeroes out this minus y. So I just have x equals negative 1. Now I'm going to plot this 0, 1, and negative, I'm going to plot the 0, 3, 3, 0 first. 0, 3, oh, I did that wrong. 0, 3, and then 3, 0. I'm going to put my point here, put it here. You'll notice I went a little bit backwards first. Then I'm going to do 0, 1, and negative 1, 0. So over 0 up 1, over negative 1 up 0, put my pen on the point, line it up. Ooh. Alright, that went a little wonky, but you can still see that it passes through here, which is an x of 1 and a y of 2. So that would be the solution. Special cases, again, draw my boxes. It's going to go 0, 0, 0, 0. Here's x, y, x, y. This is 1, this is 2. If where I place x was 0, I get negative 2, y equals 3, so y equals negative 2/3. If where I place y was 0, I just get x equals 3. So I'll go over 0 and down negative 2/3, so about right there. And then I go over 3 and up 0, so about right there. Connect the points. So my line looks something like that. For the next one, I replace x with 0 and I get 2x equals 6. Divide by 2 and I get x equals 3. I just realized I did that wrong. This would be when x equals 0. When y equals 0, sorry. So that should be negative 2/3 right here. I'm sorry, this should be a 3 right here. So if I do, when y equals 0, then my y term goes away, and I'm left with this. And then when my x equals 0, the 0 term goes away, and I'm left with negative 4y equals 6. Divided by negative 4, I get negative 6/4, but that'll reduce to negative 3 over 2. So when I graph that, I get negative 1 1/2. Oh, and over 3 up 0. Yeah, this should have been, I'm sorry guys, I messed that up completely. This should have been negative 3 1/2, so it should have gone through here. I'll tell you what, look at the next video and I'm going to redo this one.